Right, so this is Pillar 2, Chapter 7.5, Part 1, where we start looking into the modeling. But before we do the modeling, we need to learn the algebra skill on how to convert a very specific expression into another. So that's a skill we're learning. So we're not actually looking into modeling yet, but we're doing some preparatory work so that we can use it for modeling. Okay? Right, so what we're learning today, we're learning how to simplify this particular type of expression. A cos x plus or minus b sine x, or it could be a sine x plus or minus b cos x. Doesn't matter which one is cos, which one is sine. What it matters is one cos and one sine. So we're learning how to simplify this type of expression down into this type. R sine x plus or minus alpha, or R cos x plus or minus alpha. The question will tell you which one to use. Okay, so well, why, you might think, okay, why? Now, how does that help in modeling? Now, what we have to know first of all is, okay, so I'm going to explain a little bit why we need to do that, which actually leads us into 7.5 part 2 later on. We know cos x has a range of value between -1, has a range of value between -1 to 1. So as sine x, right, -1 to 1. Now, but that's not quite simple, because if you have x being a degree, let's say 90 degrees, then cos x will be 0 and sine x will be 1. So what's the problem? The problem here is if I want to find the overall maximum, okay, then I do not want to have one the minimum and one the maximum. I want to find the biggest, I want to find the best combination that can give me the maximum. But that will be quite time consuming, because cos x and sine x, they have different values when x is different. So when x is 30 degrees, you have one value in here, one value in here. So what's the biggest combination? What's the combination? What's the value of x that can give me a combination of cos x and sine x to be the maximum output? Now, if you still have no idea what I'm talking about, let's say if I substitute x is 0 in there, if I substitute x is 0, so when x is 0, there will be, let's say, a times cos 0 is 1, so a plus sine x is 0, so a plus 0 will be a. But we don't know what a is. A could be 5, a could be 4. Or if x is 90 degrees, then this will be 0, and this will be b, because sine x is 1. So depends on the value of a and b, you know, do we choose 90, 0 degree, or will actually a combination of 45 degree when x is 45 give us the biggest output? So that is quite confusing. One thing quite confusing for us to find, because if we want to find a maximum minimum, which is about modeling, having cos x and sine x is actually, you know, is actually not helping. We have two, not contradicting, but they're not helping each other to find the biggest maximum output. So one way to explain this is, imagine in a room, okay? Imagine in a room. Have you seen those light switches, like a knob, okay, on the wall? Okay, there's a knob on the wall. Okay? There are two knobs on the wall, and by turning it one way and the other, it will make the light switch dimmer or brighter. So that's a light in here. Okay, so by turning it that way or that way, it make the light switch brighter. It make the light brighter and dimmer. Now, what you will never see is, you will never see two. Let's look at Lego. You will never see two knobs to control one light. Well, why? Because one is enough, right? If one is not enough, how does two work? Now, so this is the confusing part. Imagine now you've got two knobs, right? Two light switches. By turning this, okay, one way, and by turning this the other way, it has a different brightness on the light. So imagine turning this knob anti-clockwise, okay, that way, and by this one you have to turn clockwise. It makes it brighter. So what combination it will make it brightest? Well, it's quite hard to find. So our task is to imagine that's cos x and that's sine x. It looks like a funny eye. So imagine our job is to turn these cos x sine x into just one light switch, which is either sine or cos. That will make our life so much easier, wouldn't it? So that's the whole point of today's lesson. You are going to learn how to convert these two, okay, light switches, just one down to one, either sine or cos. All right, I'm going to skip this part for now, because I'm going to show you in the example. So I'm going to show you the long way first, which you have to learn the understanding the maths behind it. When I'm teaching, I'm not teaching you just a shortcut, but I'm teaching you what to understand as well in terms of maths. Right, so put 3 sine x plus 4 cos x in the form of r sine x plus alpha, giving alpha in degrees to 1 decimal place. So step 1, wouldn't expand the R sine x plus alpha. So R sine x plus alpha equal, so sine A plus B is same as sine A cos B plus sine B cos A. So if you think about the R, you should expand in brackets, so you get R in front of each. Step 2, we can compare the coefficients. So compare the coefficients. Compare coefficients. So we can see there's R sine x cos alpha, we're matching to the first one because of the sine x, they both have sine x. And then 4 cos x can match into this one because they both have cos x. So we can write as 3 sine x equal to R sine x cos alpha. Now, if you be careful, the x and alpha do not mix them up. And 4 cos x equal R sine alpha cos x. There's a color coded for you. That's the blue equation, and that's the yellow equation. Right? So that's how I compare it. I can then simplify them. Right? So if I divide both sides by sine x, so divide both sides by sine x, and this one divide both sides by cos x, then I'll end up having on top 3 equals R cos alpha, and 4 equals R sine. There's a glitch on the board. Sorry, R. That's going to be R sine alpha. Right? Now this becomes a simultaneous equation. 2 equations, 2 unknown. The equations are R and alpha. So our job is to solve this equation. I'm going to call it equation A, equation B. Normally I use equation 1, equation 2, but I don't want to use 1 and 2 because otherwise it will confuse you with the steps number. So step 3, I'm going to solve these, just solving the simultaneous equations. Solve simultaneous equations. To solve the simultaneous equations. Well, how? First of all, I can tell sine alpha and cos alpha looks like they can make a tan alpha. So if we want to make a tan alpha, I need sine on top. So I'll do equation B divided by equation A. Right? So equation B, left-hand side is 4. Equation A, left-hand side is 3. So 4 over 3 equals R sine alpha over R cos alpha. By simplifying R and R, so that gives us 4/3 equals tan alpha. So alpha equals arctan of 4/3. Put it in a calculator, is 53.1 degree, 1 decimal place that question needs. What about the class diagram? Not important here. We're not using class diagram in here because the value of alpha has to be between 0 and 90 degrees. So therefore, we're not interested in the class diagram. That's the one and the only one answer we need, right? When alpha found his Mr. Right, yep, then that's the only one, all right? Forever, alpha equals to 3.1 for this question. Then we can find R value. So we can substitute R value. So we can substitute sub alpha equals 53.1 degree into either equation A or B. So equation A is 4 equals R sine 53.1 degree. Now, 53.1 you should also store in a calculator. If you don't remember how to store in a calculator, I'm sure you can go on Google and just type in your calculator model and ask, okay, how to store value in your calculator model, Casio, whatever, 83 GT, whatever. I'm pretty sure there must be loads of tutorials online how to show you how to do that. But if you're my student, you should know this by now. So if you put in a calculator, so 4 divided by sine 53.1, which is you should use a full value for that, equals R, you should get R equals 5. Okay. Step 4, you have to rewrite the final step. Okay, rewrite the final question. The final question that you would write is so 3 sine x plus, was it 3 sine x? Yep, 3 sine x plus 4 cos x equals to, therefore equals to R, which is 5 sine x plus alpha, which is 53.1 degree, and that's the answer, right? So we have successfully changed that 3 sine x plus 4 cos x into 5 sine x plus 53.1 degree. In other words, the 2 knobs, sine x, cos x, now just turn into 1 knob, which is sine, but this knob is a bit different. Okay, work differently because it has x plus 53.1 degree. So that's a long way. In the exam, guess how many marks this question will be? Can you guess? 5, 4? Looks a lot of marks, right? Looks a lot of steps. The answer is 2 marks because the exam do not require you to do all these steps. So I'm going to show you the shortcut, which you need to demonstrate in the exam. But however, I hope you do understand the maths behind it. All right. So it's more about understanding in here. shortcut, which you learn. Okay, shortcut. Hey, who doesn't like shortcut? Shortcut. Okay. So we use example again. We use example of 3 sin x plus. Oh, this time let me change the number. 3 sin x. Yeah, plus 4 cos x equals our sine x plus alpha. I only use the same one to show you how it works. So shortcut for the value of r. Okay, so r equals square root of the a squared plus b squared. So a squared and b squared are the coefficients of 3 and 4. Okay, so in here, so r will equal to square root of 3 squared plus 4 squared, the coefficient, which is essentially 5. See, straight away, you can get your 5 a lot quicker. Next one, for the value of alpha, 10 alpha equals, now you must say 10 alpha equals to, now this one is a bit different. This one is what we call the matching coefficients. And the top will be the other coefficient. Now, there's a reason why I fill up bottom first, the denominator, because the denominator is the one that you decide which one goes where. We also, in this one, we also ignore the negative sign. So what we're doing here is therefore 10 alpha equals, now what do I mean by matching coefficient? The question wants sine. So therefore the sine coefficient will be underneath. So 3 was the coefficient of sine, therefore 3 will go at the bottom and 4 goes on the top. So I'll just show in here. So 3, okay, so question, okay, has sine. So coefficient of sine is the denominator. Okay, and then you can find alpha quite easily. So arctan of 4/3, you will see, which is 53.1 degree, and that's your 2 marks, right? So what I'm just one more thing. What do I mean by ignore negative sign? It means if it's a 3 sin x minus 4 cos x, you will ignore the negative completely. So you just still put 4/3. If there's a minus in there, it doesn't matter. But why? Because if it's a minus in here, the question will have shown you the minus in there. All right, so the minus will be taken care of naturally by the question. So you don't have to worry about a negative. So again, ignore negative sign. All right, otherwise your answer will be out of range of between 0 and 90 degrees. Okay, right. And the next one is the practice. So what I want you to do is I would like you to pause the video, okay, and practice the long way just to make sure you understand the long way. And then if you can, try the shortcut as well. So when you're ready for the answer, you can press play. So this is the final answer, root 29 cos theta minus 68.2 degree. I'm not going to show you the long way. I'm just going to show you a shortcut. Okay, shortcut is, so r equals square root of 2 squared plus 5 squared. By the way, if you can do the full working out the long way correctly, well done to you. Okay, it just shows you understanding of the numbers and the algebra in between. So r equals 2 squared square root of 2 squared plus 5 squared, which is root 29. So straight away, and the 10 alpha value, okay, 10 alpha value is, now this time they want cos. There's a cos in the question. Therefore, the cos coefficient goes underneath 2. Therefore, the 5 will go on top. So arctan of 5/2, or inverse sine of 5/2, is 68.2 degree. And therefore, don't forget to write the final answer. So 2 cos theta plus 5 sine theta equals root 29. Cos theta minus, the question is minus. Well, why minus in the question? Why minus? Because remember, cos A minus B equals cos A cos B plus sin A sin B. And that's why you can see it's all taken care of. Don't worry about that. As long as you follow the question. So theta minus 68.2 degree, and that's the final answer, right? We're going to use this answer for the next question. Example, question A, okay? Put 2 cos theta plus 5 sin theta in the form of r cos theta minus alpha in terms of degrees. Now, we've done this in previous, so that's why I want to save time. So, so we know, I'm going to just rewrite this just for the sake of completion of notes, equals root 29 cos theta minus 68.2 degree. You can refer if you know, if you want to read the notes one day and realize how do you get the one line, you just say it's from previous example, or you can say page number, whatever, you know. All right. So next, part B, sketch a graph of y equals 2 cos theta plus 5 sin theta. We're not gonna use 2 cos theta plus 5 sin theta because we've done the hard work to change it into hard work, 2-minute work. Root 29 cos theta minus 68.2. So instead of sketching a graph of 2 cos theta plus 5 sin theta, we're going to sketch a graph of root 29, that one. So part B, we're going to sketch y equals root 29 cos theta minus 68.2 degree instead. Now, and the benefit of this is rather than sketching 2 trigonometry graph, which is quite weird, combining into one, we just now have one trig function, which we can sketch it quite easily. So think of it as a parent function as a cos theta. So imagine f theta equals cos theta. Now tell me how many, as in do you think about yourself, how many transformations are there in this equation? There are 2, negative 68.2 and root 29. So negative 68.2, so f of theta minus 68.2 degree equals cos theta minus 68.2 degree. So this, you're moving to the right, move right by 68.2 degree, right? And then the last one, you've got, and also you've got root 29 f of theta minus 68.2 degree. So root 29. Now, you must know the order of transformation you've learned in chapter 2, which is has to be from the inside bracket all the way to the outside. Therefore, we have to do them moving first because the negative 68.2 is inside bracket and then root 29 outside bracket. This one is a stretch in y by root 29. So what we can do is let's sketch the original first. The original of cos theta graph, that's the original, OG, original, which is cos theta graph like this, right? So put in some key values, 0, 90, 180, 270, 360, 1, minus 1. So the question needs us to move to right by 68.2 degree. So now I'm going to make this graph quite messy because this is just a sketch. So 0, this will become 68.2. So that means we'll move the graph to right by 68.2. So you can do as many graphs as you want. So if we move the graph to right by 2, that means, can I actually do that technology? Did I just pinpoint that? Can I just make that line? No, I can't. Okay. So I was hoping if I could just move the curve. No, I can't. So if I move to right by 2, that means the hidden part on the negative degree will now comes into play. So it will look like this. Okay, and we're just going up to 360 degree. Okay, so this was still 0. But now this highest point where it was 0 becomes 68.2 degree. So just to make you aware of that, if we call this point A, this is the freezing point A. This point B is now here. This point C is here. And this point D is there. So you might be asking, what about this point E in here? Point E is gone the last point because we moved the graph to right by 68.2. So that will be now our 360 degree range. So now let's keep us. So point B, 90 plus 68.2 is 150, 68. Can't do the maths. So 90 plus 68.2 is 158.2. 158.2. Now that's why when you draw a graph, it's best to use a pencil. 180 degree on point C plus 68.2 now becomes 248.2 degree. And point D, where it was 270 plus 68.2 is 338.2 degree. And because we're stretching in y by root 29. So all the y coordinates times root 29. So 1 times root 29, minus 1 is minus 29. And that's your final answer. And that's why we can use, that's how we can use this function here, making. So what we'll learn today, we're learning how to put 2 funny knobs into one. And we're going to use this skill a lot for the next few lessons. All right. So, yep, that's it for, oh, we're not done yet. Sorry, are we done yet? We're not done yet, are we? Oh, we're not done yet. Part C, sorry. Hence, solve the equation. Hence, do you think they want you to use part B or part C? Oh, wait, do you think they want to use part A or part B? Part A, okay? Part A, because part A helps you change in that format, which is easy to use equal 3. This graph is not useful, but if you want to make equals 3 means, graphically, equals 3 means a straight line through here. Root 29 is around 5 point something, that's here, so that's 3. But how does it help us to locate the answer? There's not a plot, there's a sketch. So it only tells us how many solutions are there, but it doesn't tell us what's the exact value. So therefore, part B is not useful, but it's just not very useful. Okay, it's like the bus timetable. Is it useful? Yes, but can you rely on it? Maybe not. Right. So part C. To solve the equation 2 cos theta plus 5 sine theta equals 3. First, let's do a bit of makeup. So change the 2 cos theta plus 5 sine theta from A, so from part A, we're going to change it into root 29. Now, this skill is going to be useful in modeling, which is the same skill. Convert the equation into this format from part A, because now we can solve it quite easily. So to find theta, first get rid of root 29. So cos theta minus 68.2 degree equals 3 over root 29. Now, when you see equation like this, don't fret. Step by step, think about what you want to find. You want to find theta. So theta is the most inside layer. So like an onion, peel from the outside. Root 29 was the most outside layer, the brown layer. Remove it, divide to the side. That's a times, so the other side is divide. Now it sounds, why are you teaching GCSE algebra again? Solving equation. The reason being is when students see equation like this, sometimes they just go off tangent, and some pun intended. But you don't want to mess up basics like this. Okay, so even small basics does matter in maths. So have your basic correct. So divide by root 29. And then if I want to find theta, you've got 2 things to get rid of. Cos and minus 68.2. But we can see cos is the furthest outside now. So we have to get rid of cos. To get rid of cos is the opposite of cos, which is arc cos, inverse cos. So theta minus 68.2 degree equals arc cos of 3 over root 29. And as soon as we see arc cos, we know we have to do cos diagram. And if not, I haven't told you already, in part B, we know there are 2 solutions, haven't we? So we know cos diagram must come into play. So let's put arc cos of 3 over root 29 in calculator. It's in degrees, which we love it, but my calculator is not. So, yep, so 56.1 degree is what I've got. So 56.1 degree, 56.1. For cos to be positive, the other answer is here. So 360 minus 56.1. So theta, keep the left-hand side. We haven't done anything on the left-hand side. We'll work on the right-hand side. Equals 56.1 degree or 303.9 degree. Then you add 68.2 degree, okay, to the right side. Add 68.2 degree. So that gives us 124.3 degree or 372.1 degree, which is rejected. Now, this out of range, rejected. But we said there are 2 answers. How is that possible? Because there was one that was before. That was in a negative, but okay, because there was an answer that was in a negative. So if you look at this graph on the left hand side, OG graph, there was an answer in here, but now this answer, if you bring to the right hand side, is this answer here. That's what happened. So how do we find the more answer? How do we find second answer? Well, after we find the principal solutions, we either take away 360 or add 360. In this case, we take away 360 for both answers. So 124.3 minus 360 is that one, to be honest. If you work ahead, you will realize that it's negative degrees, so that's rejected as well. But if you do 372.1 minus 360 is 12.1 degree, which is what we need. Therefore, theta equals 12.1 degree or 124.3 degree, which if you look at it, it matches with what we drew in here, 12.3 and 124.3 degree in here. Okay. Now I'll explain again. It looks simple what I did, obviously, because I've done it many times. But for you, it probably is not that simple. It's not as straightforward. Your task is to do as many questions to make it look natural, to make the skill natural. Like when you learn to drive, if you don't drive often, you will forget how to drive. You need to pick it up. But when you're in an exam, when you're in a car, in a theory test, in the what do you call them again? A driving test. You can't be rusty. You should be showing some fluency in your driving skills. Same as algebra. So I would say again, from pi, we turned it into it. And then to find theta, step by step, root 29 on the other side, arc cos. As soon as I arc cos, I realized through the cos diagram, I found my two answers like I normally do. And then I plus 68.2 degree. And then nothing really triggers me to think about finding different answers until here. I realized this answer is too big, 360. Then I either plus or minus 360 to find the other. So if you plus 360, it wouldn't make sense either because you'll make the answer bigger and bigger. But if you minus 360, you get a smaller answer, which one what you need. All right. So every step, there is a reason behind it. Okay. So that's what I'm teaching you. Okay. Why do we do that? Why do we do that? So why? Okay. Right. So that's chapter 7.5, part 1. Next lesson, we're going to learn how to use this function more, about finding maximum and minimum, about how to find the brightest and dimmest light using one light knob switch.